Right, in homework 7 we're looking at some absolute value inequalities. Now before you start this video, I strongly suggest that you go back and check the homework video for homework 3 about solving absolute value equations before you do this, because we're using the same idea of breaking points and using the regions in a table. So here, let's try this now. First we need to find the breaking point here. We can see that it's 4 and here -1. So we're going to draw a table. I'm going to draw it over here just because we want to try and save a little bit of room here. So -1 is this one and 4 over here. So let's see, hopefully we have enough room. If we pick something here to the left of -1, let's say -2, then 4 minus -2, that's going to be positive, so that remains the same, 4 minus x. And we're just going to try and find the value, so we're going to ignore the inequality symbol and just treat it like an equation, and just for now. And then we're going to see that if we pick -2 here, then we'd have -2 minus 1 is going to be negative, so we'd have -x minus 1. Pick a value in the middle here, let's say 0, 4 minus 0, that's positive, so that stays the same. And if we pick 0, then this on the right hand side would also be positive, x plus 1. Something bigger than 4, let's say 5, the section on the left is now negative, so that would mean x minus 4. And 5 makes this positive also, so x plus 1, nothing changes there. Okay, hopefully this is enough room for us. So now let's solve these equations very quickly. -x minus x, adding x to both sides, that would cancel. 4 is never equal to -1, so empty set. Here let's add x to both sides, so 2x, and subtract 1, we get x equal to 3 over 2. And over here, if we subtract x from both sides, -4 is never equal to 1, so that's the empty set. Alright, so now we have to draw another table. So let's do this over here. And we've got one important value here, this 3 over 2. So these are the regions that are going to be important, above or below this value of 3 over 2. These are x values, remember. Alright, so now we're going to test a point and see if it's true. So let's say we try something to the left of 3 over 2. Something lower than that would be, I don't know, 1. So if we pick 1, let's say, try 1, we would have 4 minus 1, absolute value. Is that less than absolute value of 1 plus 1? So what we're saying is 3 less than or equal to 2? And that is quite clearly false. Alright, so now let's try something bigger than 1 over 1.5, so that's, let's say, 2. And so let's try this. Is 4 minus 2 for x into the original inequality, is it less than or equal to 2 plus 1? So what we're saying is 2 less than or equal to 3? I think we can agree that that is true. So what that means is that this entire region to this side of 3 over 2, and including, because of this line underneath the inequality here, all of these values are part of the solution set. So when we write the solution set as an interval, it looks like this with the square bracket at the 3 over 2. Alright, so that's basically how we do it. So this section on the left was the same as the equations, and then just one extra step to check the regions. So let's have a go here at another one. So here we can see that the breakpoint here, 2x minus 6, well, if x was 3, that would be 0. So 3 is the breaking point, and there's only one of them. So hopefully that makes it a little bit easier for us. So 3. And now let's pick something less than 3 to check if it's positive or negative. So let's try 0. If we make this 0, that's going to be negative. So we'd have minus, well, that 6 is negative, so let's say positive 6 minus 2x. Minus 4 plus 3x, and remember, just treating it like an equation. So if it's bigger than 3, let's try 5. So we'd have 2 times 5 is 10. Well, this is going to be positive. 2x minus 6, and the rest of it as is written. Let's solve these equations. So we've got minus 2x plus 3x is just going to give us x. We have 6 minus 4 gives us 2. Subtracting that from both sides, x is minus 2. 2x plus 3x gives us 5x. And we have minus 6 minus 4, that gives us minus 10. Add that to both sides, and we have x equal to 2. All right, so those are our important values. So here we'll draw up our second table, the inequality test. And the values that we're interested in are minus 2 and 2. So we have 3 regions here to check. So let's check if we have something less than minus 2, let's say minus 5. So if we have minus 5 in here, we have minus 2x, so we'd have minus 16, so that would be 16 in absolute values. Minus 4 plus, let's say it'd be minus 15. Is that greater than or equal to 0? All right, so let's see. If we've got 16 minus 4 would be 12. So is minus 3 bigger than or equal to 0? No. So this region is not included. All right, so let's pick something in between minus 2 and 2, maybe 0. So then that in case we'd have 6. The absolute value of minus 6 is just 6. Minus 4, and the 3x would be 0. So is that bigger than 0? You betcha. So this region is okay. Now let's try bigger than 2. For bigger than 2, if we have 4, let's pick 4. So we'd have 8 minus 6 would be, an absolute value would be 2, minus 4, and then plus 12, 3 times 4. Is that bigger than 0? Well, we'd have minus 2, we'd have 10 bigger than 0, then that's definitely true. So this region is also included. So if we look at this as a whole, what we can see is that this whole section here, and considering that the values are included, minus 2, all of these values are included in our solution set. So that's what's written over here. Minus 2 all the way up to infinity, and the bracket's been left off there. Remembering that we're looking at all the solutions in all real numbers. All right, so for question 3, same sort of deal. Let's find the breaking points. 5. 2x minus 3, this is a little bit more difficult. Let's solve this equation. So 2x would minus 3 would have to equal 0. 2x would have to equal 3. X would be 3 over 2. So those are going to be the values in our table. So 3 over 2 here, and 5 is bigger than that. All right, so let's check these values here. So let's pick something less than 1.5, let's say 1. That's going to make 5 minus x positive, and 1 makes 2 minus 3, well, that's going to be negative. So we'd have positive 3 minus 2x. Let's just consider the value, so equals 9. In the middle here, let's pick 2. 5 minus 2, that's going to be positive. 2 times 2 is 4, minus 3 is also positive, so plus 2x minus 3 equals to 9. And let's say 6, so 5 minus x is going to be then negative, so x minus 5. 6, I'm going to make this positive. 2x minus 3 equals 9. Okay, so let's solve these. I hope you've paused the video and are trying this for yourself. Let's see, we've got minus 3x. Oops. Minus 3x. And we have 8, so subtracting 8 from both sides, and we get 1 there. And so dividing by minus 3, we'd have x equal to 1 over minus 3. So how are you going? There's lots of algebra to do here. Let's continue, troop on. So minus x plus 2x, we've got x. And we have 5 minus 3, that's 2. Subtract that from both sides, x equal to 7. Like terms over here, we've got x and 2x, which gives us 3x. And minus 5 minus 8, if we add that to both sides, we get 17. So we have x equal to 17 over 3, which, if we want to think about this, is about 18, so about 6. So right, so we have some values here that we need for our table. We've got minus 1/3, we have 7, and we have 17 over 3. All right, so let's draw There's some space over here. Let's draw a number line with 3 regions. It'll be 4 regions, in fact. My mistake, because we have 3 values this time. All right, so 1, 2, 3. The smallest one is obviously minus a third. Then 17 over 3 comes in, and then 7. All right, so let's see how we go with this space here. Let's now test some values. So less than minus a third will be minus 1. So let's see. We've got minus 1 here would give 6, absolute value of 6, plus, now if we had minus 1, this would be minus 2, which makes the whole absolute value 5. 6 plus 5 bigger than 9? You betcha. 11 is bigger than 9. All right, so now in the middle here, let's pick 0 would be in the middle. That's a nice easy one to check. So if we have 0 here, we have 5. And here minus 3, which in absolute values means 3. Is that bigger than 9? No, it isn't. 8 is not bigger than 9. So something between 17 over 3 and 7. Well, 6 is actually in between there. That's a nice integer value to use. So let's see if we've got 5 minus 6, that's going to be minus 1 in absolute values is 1. 12 then, 2 times 6 is 12, minus 3 is 9. So plus 9. Is that less than 9? Let's see, 10 is not less than 9. No. Okay, so then for 7, let's try x is 8. So then we'd have 5 minus 8. So that gives us minus 3. In absolute values, that's 3. And if we have 8, we got 2 times 8 is 16. Minus 3 gives us 13. 3 plus 13, is that bigger than 9? Yes, it is. 16 is bigger than 9. So we have these regions here. Now notice that this time our values are not included. So we have a hollow dot. So it's this region and this region, and there's a mistake in these solutions. That 17 over 3 should in fact be a 7 to infinity. Okay, hope you enjoyed these videos, and we'll see you in another one.